Welcome to Evidence Strong News. My name is Alex and we'll be discussing the newest and best research in Olympic weightlifting. Let's go! Okay, the first study coming from Saudi Arabia and Egypt. Isokinetic assessment of shoulder joint strength ratios in male recreational weightlifters, a cross-sectional study. So the researchers recruited 30 male recreational weightlifters from local fitness clubs with the average age of 22 years and looked for non-weightlifting males in the same age to match them. And then they measured the normalized concentric peak torque for shoulder flexors, extensors, abductors, adductors, and external and internal rotators at 120 degrees per second on Biodex. And at the end, they calculated the ratios of muscle groups to compare. And they have found that weightlifters had higher values of normalized peak torque than non-weightlifters. But what was interesting was that the ratios of abductors to adductors and external rotators to internal rotators were lower in weightlifters than in non-weightlifters. Now let's compare how these muscle groups are used in training. So adductor muscles were the most targeted muscles in training, 94%. Then shoulder extensors, 75%, flexors, 73%, internal rotators, 71%, and then shoulder abductors, 19%, and external rotators trained the least, just 12%. So flexors and extensors were trained similarly, about 70%, and their ratio was not significantly different than the ratio from non-weightlifters. But the difference between abductor muscles and abductor muscles was huge, between 94% versus 19%. And the difference between internal rotators, 71%, and external rotators, 12%, was also big. So these differences may indicate the higher risk of shoulder injury in weightlifters comparing to non-weightlifters. But again, it will depend probably highly on the way they are training, so keep it in mind. So if the weightlifter has recurring shoulder injuries, it may be worth looking into strength of all the group and see whether there are some deficits in any of the groups. Okay, the second study comes from Taiwan and it's titled The Analysis of Upper Limb Movement and EMG Activation During the Snatch Under Various Loading Conditions. Unfortunately, we have access only to the abstract of this study, but let's try to get something out of it. So the authors used motion capture systems, so they probably put markers on the lifter's body, specifically upper part of it, and they use EMG systems, so they put electrodes and tracked electrical activity of the muscles of the upper body. So what they found is that during the snatch, as they went heavier and heavier with the weight, the maximum flexion of the shoulder joint exceeded 180 degrees. They also found that deltoid muscle and biceps muscle activity increased with the increasing loads. So biceps and deltoid were activated more in second pull as the load progressed, and during the first pull, latissimus dorsi activation was increased when the load was increasing. So to sum up, first pull, activation of latissimus dorsi has to increase. In second pull, deltoid muscle and biceps, and deltoid muscle and biceps have to also increase activation in the race phase. I'm not quite sure what the race phase is. Alright, another news. Evidence Strong has a Patreon community where you can access all our content in one place and early. And also, we have the extended versions of interviews with researchers, and every month we do a masterclass on the topic you guys choose. So if you want to upgrade your weightlifting research knowledge, that's the place to be. The last study for today comes from Spain and is titled Optimal Load and Power Spectrum During Snatch and Clean: Differences Between International and National Weightlifters. So the authors recruited 22 male weightlifters and invited them to 2 testing sessions. The first one was to test their 1 repetition maximum in the snatch and clean, and in the second session they tested power across the loads from 30 to 90% of each lifter's 1 repetition maximum. The power was calculated from the load and barbell acceleration, and they used 3-axis accelerometer from Pasco. So the authors found that for snatch the differences between the groups were significant, above the 50% of 1 RM, and for clean above the 70% of 1 RM for peak power. So what was interesting is that for international weightlifters, peak power was the highest highest at 90% in both lifts. For national level weightlifters, peak power was the highest at 70% in the snatch, and there was no difference in peak power between 70, 80 and 90%. In the clean, the peak power was the highest at 90%, but there was no difference between 50, 60, 70, 80 and 90% in peak power. Okay, so what it means. In international weightlifters, the optimal power spectrum was found between 80 and 90% of 1 RM for snatch, and there's no spectrum for clean. And for national level weightlifters, optimal power spectrum for snatch was found between 70 and 90% and between 50 and 90% for clean. So if you're after training power, you can use spectrum of loads for national level weightlifters, but you have to be a bit more precise for international level weightlifters. Please remember that strength of the athlete and the technical proficiency will also play a role when the power peak is considered. So please use these optimal power spectrums to best develop power output. That's it for today. See you next time.